But what we're gonna add is finding a
Don't balance
rate,
out.
and that's where we'll put the time from the graph on the bottom. And then we'll do, what does delta mean, guys?
The change in.
Final minus
Initial.
initial. And see, this is gonna help us find the rate for each and every one. And what you're gonna see now is, once we've done all this work, this actually provides us with the equivalent of the data table that we saw in the previous problems.
Can you go back one slide really fast?
Yeah,
Where are we getting 0.375 for?
I'll be right back there in a second, once he's good with this one. You guys excited? May 2nd is coming.
What's up with May 2nd?
That's the AP exam.
Oh my
Yeah, but
goodness.
like what else? Besides the 2 AP exams on that day, what else is on May 2nd?
Oh wow, I just realized something. We're doomed.
What do you mean?
Yeah. What?
Because May 2nd is before May the 4th be with you.
Oh, I have my CSA test on that day. That's for CSA.
Shut up. I don't want to talk about
You guys won't have the 4th with you.
You're hilarious. I'm sure you're a blast at parties.
There's no chemistry in Star Wars.
Logged into my college board account. Is that going to be an issue?
Probably you should work on that. Do the password recovery or whatever.
No, it's not password recovery.
See, to me, what's special about May 2nd is the last day we have to do
It's
chemistry.
migrating your account. And then I'm like, okay, let me use a different email.
Yeah, so you gotta call them. You gotta call and wait on customer support for like hours.
That's not fun.
That's too responsive.
All right, but you gotta do it.
Oh, I can't say that.
All right. So anyway, let me go back here. So what were you asking? You were asking where what came from?
0.375.
I think that came from here, where see it's between 0.25 and 0.5.
Why do we look at that point then?
Oh, because that's this point here, 60 seconds.
So we look at it when it's 60 seconds raw?
I think that's what we did. Hold on.
No, didn't we use the
Yeah.
second
We're
experiment?
looking at all of them for 60 seconds.
Okay, so you have to look at it. Okay.
Hey, welcome, sir. Hey, so what's her name? Miss Hartzell was calling for you.
Oh, she was?
Yeah, do you want to go check in with her real quick? You know where her office is?
I did. Let me go for myself.
Yeah.
Yep, see, something.
You can't say it.
Can't say it, bro. Oh, can't say it. Give us a deal.
All right. Any other questions at this point so far? So basically, we're choosing all of these from the point 60 seconds. And we're doing this to find the rate.
Wait, how come specifically 66? Oh, so yeah, like I see, like at 60 seconds, those are the absorbances, but
Yeah, so I think you could have used it at any time. We're just choosing 60 seconds.
okay, at any time that's not 0, or could you still do 0?
It's probably better to avoid using an A of 0. That's probably why we don't want 180 seconds, because you see how this one's at 0.
Oh no, I mean like t is 0.
Oh, yeah, because we used, we are using the t as 0 because we're subtracting.
Okay, that makes sense.
Like we're subtracting the times, that's why it's 60 seconds.
Yeah.
Oh, and also, yeah, we have to because
Oh, yeah,
these are
because
the
we're
ones,
finding the rate.
these are the initials.
Yeah.
All right, guys, anyone need these still?
Wait, I have a question.
Yes.
Okay, so for A, why do we use the same A value in all experiments?
The same what for all experiments?
The lowercase a value?
Oh, because we calculated it.
Yeah, but why is it the same? Because didn't we just calculate it? in
No,
the
because these are 3 different experiments for the same reaction.
Okay, I see.
Yeah. All right, guys, let's move on here. So the reason we did all that work just now was to make ourselves a chart. Oh, look, it it looks just like the chart of the problem we did earlier. So now we can solve this the way we did the earlier one. Notice, where's the overlap between 1 and 2?
1 and 2.
With reactant B. And where is the overlap for reactant C?
1 and 3.
1 and 3. So instead of 2 and 3, this time it's with 1 and 3.
Are the purge fans still down?
The what?
The purge fans.
Can you speak English?
Checking.
Yeah.
Okay.
All right, guys, let's move on here. Anyone still need this one?
Yeah. You guys liking kinetics so far?
No.
It's not terrible.
I
It's
like
not
Simon.
terrible.
You know, it's-
You know what? It's one of those ones. It's one of those ones where, guys, kinetics bark is far worse than its bite. When you actually sit down and practice it, it's not going to be that bad. It just looks bad. It's not bad at all, though. Because, guys, before I even move on, you already know how to solve this. We're just going to put rate law of 1 and 2, 1 over 2, right? Or maybe we'll do 2 over 1, because that way it's this over that, and that'll be 2, right? And then we'll do
1
1
and
and
3.
3, probably 3 over 1, because you know 8.3 over that. And then you find M and N that way,
Mm.
and then you plug everything in with M and N, and then you find K. That's it.
So, hold on. So this whole thing was to find the reaction
The whole thing was
constant.
to create the same setup as we had in the previous problem.
Okay,
That was it. That was the whole reason for everything.
that's dumb.
And now we can do what we did.
In the problem
in the
before this
problem,
problem.
But like we did everything this time.
Yeah, we had to create the chart this time.
So this is gonna be like FRQ type stuff.
Yeah.
How much more is left?
Of the lesson?
Yeah.
How much of the AP test is?
Like
We're almost
a
done.
few slides. I think this is the last exam.
We're almost done because remember a lot of those slides are technically just adding things on the same slide. All right, guys. Are we good? Okay. So we're gonna do experiment 3 over experiment 1 here. And remember, it doesn't matter which one you put over the other one. It's just a personal preference thing. I think typically it's recommended to put the higher one on top because then you can kind of eyeball it, right? That this one would be 2, right? But you know, it's up to you how you want to do it. So guys, what are we crossing out now?
1 and 1. Oh.
The point 1 and the point 1, right?
And the K's.
And then can I cross out the K's as well?
Yeah.
Yeah, I can.
Okay, and then it's just 2 equals, and then 0.2 over 0.1, which is 2. So guys, 2 equals 2 to the n. What must n be? 1, which is what order? First order, not to be confused with the horrible villains from what Disney decided would be Star Wars.
Oh.
Oh my god.
Ouch. Dang.
You better be.
Wait, why is it?
Mr. Wire, you're gonna get Scott a walker or something?
No.
Oh, it's white, so it's not 2.
Better be getting it.
Oh,
I'm
'cause
gonna
the
be
other
good.
I already
example-
Oh, yeah, so this
Oh,
one can be kind
I
of tricky,
got
right?
you
Because you
right
see a
here.
bunch of 2's right here. But remember, it's 2 equals to the n. So n has to be 1.
Oh, okay.
I've made that mistake before. I'm just going to confess that right now.
Okay.
Because you get so excited because you get a 2 right here. So just watch out for that. You're solving for n. So actually, now that you raise that point, I do remember there's one teacher I encountered who actually always advised kids to put the lower number on top because then there was no risk of that you would have had a decimal.